All right. Hello, pre-calculus students. This is a trig review to just go over some of the basics. So this is a supplement to 4.1. So this is the trig review of angles. So take notes on line paper to supplement 4.1. Okay, so this is one of the things is that you need 4.1 to understand 4.2, 4.2 to understand 4.4, 4.4 to understand 4.5. So if you're getting lost, it's probably because you missed something initially, which is causing you to seize up a little bit. So, anyways, let's make a review for angles. For trig review angles, theta. That sign means theta, and it designates an angle. Each angle is going to have an initial side and a terminal side. Sorry about this sneeze. So initial sides. An angle, if you actually think about the definition of an angle, it's a rotating array about its endpoint. And here the endpoint is the vertex, and our initial side, let's get two things to represent the angle, right? This is going to, you start at the initial side, and then your angle is going to rotate, and an angle moving in a positive direction is we're going to rotate counterclockwise to its terminal side. All right, so that is the terminal side, and this is the initial side. So positive rotation, you're going to be rotating counterclockwise, and with the negative rotation, you're going to be rotating clockwise. Just want you to make a note that the most that a ray can rotate is a full circle rotation. That's 360 degrees before a ray is back to its initial position. Let's explore that. We start at our initial position, and the most we can rotate is 360 degrees, but to be more accurate, just a full circle rotation. So we've rotated 90 degrees, or a quarter circle, 180 degrees, or a semicircle, 270 degrees, or 3/4 of a circle, and then 360 degrees. And then we rotate a full circle and we're back to where we started. If I rotate any more past that, then it's just like I rotated a tiny bit. All right. So then let's talk about what a degree is. A degree is an arbitrary fraction of a circle rotation. So it's 1 over 360th of a full circular rotation. So I should say a full circular rotation. So that says circular. L-A-R. Circular. Now, coterminal angles. Let's look at positive and negative degrees. The whole idea with coterminal angles is that they have the same terminal side. Essentially, they land in the exact same position. They are one full circular revolution away from each other. So I'll just look at an example with degrees. Coterminal angles, these are all coterminal angles. Negative 405, negative 45, 315, and sorry, I didn't write this well, but this says 675. And the reason why is because all these values are full circular rotations away from each other. So at least in terms of degrees, you can add 360 from 405 to get to 45. Add 360 to get to from negative 45 to 315. Add 360 to get to 675. And you can keep on adding 360 forever to get coterminal angles in the positive direction. And you can keep on subtracting 360 forever to get coterminal angles in the negative direction. Now, let's just look at an example here. So this example says we have an angle of 315 degrees and then an angle of negative 45 degrees. So we can take our pencil and rotate it 315 degrees. Keep rotating. Not exactly the prettiest rotation, but I've rotated it 315 degrees, and here, this is definitely one I can zoom out for. Or I can start at the initial position and just rotate negative 45 degrees. And I'll end up in the same terminal position. So, positive 315, rotate 315. I could also rotate 675, which would be like starting here, rotating 315, and then rotating another 360. And then back to this angle where I started. So 315, 675, negative 45, negative 405. So negative 405 would be like negative 45 minus another 360. Rotating that pencil. That's where it would lie. So those are coterminal angles. You have to add full circular revolutions away from each other. Just a hint, we're going to cover radians later, and radians, it's going to be plus or minus 2 pi for radians instead of plus or minus 360. So, we don't have to know arc length, but you do have to understand it to get radians. So an arc length for an inscribed angle in a circle, the arc length is the proportion of the circumference inside the angle's rays. So let's look at, for example, this angle right here. Inside these rays, I have a 225 degree angle. And the arc length is the proportion of the circumference inside. Yeah, so assuming the radius is 1, the circumference is the distance around an entire circle. And the circumference is found by 2 times the length of the radius times pi. So here the circumference is 2 times 1 times pi, because we're assuming that the radius is equal to 1 here. So 2 times 1 times pi, the circumference is 2 pi. Now our arc length, let's just do an example here. When our theta, our angle, is 225 degrees, arc length is going to be 225 degrees over 360. That's our angle. Times 2 pi, which is the circumference. So that's the angle over 360 times 2 pi, which is the circumference. 225 over 360 is going to simplify to 5/8. Simplify that fraction. Times 2 pi. The circumference when we're assuming the radius is 1. So 5/8 times 2 pi is going to become 5 times 2 is 10. Times pi is 10 pi. 10 pi over 8 is going to simplify to 5 pi over 4. Huh. Doesn't that look kind of similar to 5 pi over 4 from the unit circle? Anyways, simplify that fraction. So that's the arc length there. That's just one example. So that's one example of arc length. So, and then once again, when the radius equals 1, the circumference is 2 times 1 times pi, which is equal to 2 pi. Now we've been talking about radians. I just wanted to hit it home what a radian is. A radian is an angle that produces an arc length with the length of the circle's radius. So when the radius is 1, the arc length is equal to 1. So x over 360, the angle over 360 times 2 pi is equal to the arc length. Here the arc length is 1. So the arc length is really, we're just making sure the arc length is equal to the radius. We can say this is equal to r if we wanted to. So x over 360 is equal to 1 over 2 pi, which means that x is equal to 360 over 2 pi, or 360r over 2 pi. 360 over 2 pi is equal to 180 over pi, just simplifying that fraction. And 180 over pi is approximately 57-ish. That's not exactly it, but that's, you use your calculator. All right? This is the measure of the radian because the arc length is equal to the length of the radius when the radius is 1. So we're looking at an example of this arc of this situation here. So we have an angle, a central angle of 1 radian. So that's really small, but that says 1 radian, which is approximately 57 degrees, not quite. And we have an arc length of 1. So if this circle were a track, the distance to run this angle of the track would be 1 when the radius is 1. And then the distance to run a full lap around this track would be 2 pi. And if pi is 3.14, that would approximately be 6.28. So the circumference is 2 pi, right? So that's approximately 6.28 whatever unit you're going to be running in, assuming this is a circular track. One last point I want to make is for reference angles. All right, reference angles are the acute angle formed by the terminal side and the x-axis. And this is for find step 1, just you're going to find the standard angle in between 0 and 2 pi. So once again, if you're getting an angle that's not in between 0 and 2 pi, find a coterminal that is. So out of all these coterminal angles, 315, well, it's in between 0 and 2 pi radians and 0 and 360 degrees. So find the standard angle, figure out which quadrant you're in. If you're in quadrant 1, your reference angle is theta. Quadrant 2, reference angle is 180 minus theta. Quadrant 3, reference angle is theta minus 180. Quadrant 4, reference angle is 360 minus theta. Now, if you're in radians, then this is going to be pi minus theta, theta minus pi, 2 pi minus theta. All right? So that's the video. Also, I want you to note, see those 4.1 notes. So remember, if you're stuck, have a double dose of understanding for 4.1 because 4.2 builds off of 4.1, 4.4 builds off of 4.2, and 4.1, 4.5 builds off of 4.1, 4.2, and 4.4. All right, so I want to make sure that you have access to resources because I want there to be less excuses for you to get caught up and stuck. All right, have a great night.